CQC, Chapter 5, Extra-Dimensional Non-Locality and Quantum Mechanics. We now enter Chapter 5, Extra-Dimensional Non-Locality and Quantum Mechanics, followed by Chapter 6, Mechanics of the Invisible. Here as well, we will use precise mechanical analogies and simple formulas to explain phenomena that modern physics describes only using abstract probability functions. 5.1 time is a relative brane lattice sliding parameter. In cyclic quantum cosmology, time is not treated as a rigid orthogonal coordinate intrinsic to a fixed four-dimensional manifold. Macroscopic time t is a relative sliding parameter. It measures the kinematic progression of our 3-brane M4 as it moves through the bulk and slides across the static lattice of space strings. The effective time coordinate on the brane is linked to the sliding velocity y equal tau dy according to the geometric relation. dt equal to gamma d tau equal 2n VCRT, where VCRIT is the limiting sliding velocity of the brane in the bulk. Gravity, from this viewpoint, manifests when a local mass locally deforms the space string lattice. This accumulation of elastic tension flexes the brane, locally slowing down the relative sliding and mathematically producing the phenomenon of gravitational time dilation in general relativity. In classical physics lectures, time has always been described as a background variable, or in Einsteinian relativity as the fourth coordinate of a fixed grid. In CQC, we change perspective. Macroscopic time is not a rigid coordinate, but rather the result of a relative motion. It is the measure of how much our brane moves along the fifth dimension of the bulk, sliding across the lattice of space strings. Imagine a train running on an infinite track. The railway ties are the strings. The conductor's time is nothing more than counting the ties passing beneath the wheels. Mathematically, the speed at which the brane moves in the bulk along y relative to bulk proper time determines the rate of time t in our universe, dt equal to gamma d tau equal 2n VCRIT, where VCRIT is the limiting sliding speed of the brane. If a mass locally deforms the space strings, the brane curves and slows down its relative sliding. An observer located on that mass will see fewer ties passing by, experiencing what Einstein called gravitational time dilation. 5.2. The quantitative limbo, extra-dimensional transit, non-locality, and the explanation of entanglement. CQC offers a geometric and mechanical explanation for the mysteries of quantum mechanics, such as wave function collapse, quantum entanglement, and Heisenberg's uncertainty principle. To do so, it introduces the concept of quantitative limbo. When a photon or an elementary particle transitions from one state to another, or when two particles are entangled, quantum information does not travel along the two-dimensional lattice of the brane. Instead, it performs a microscopic jump through the extra-dimensional bulk. Temporary disconnection during a quantum transition or measurement, the string involved temporarily detaches from the surface of the brane M4. Shortcut in the bulk. Upon entering the bulk, the string enters a region devoid of the brane's induced metric gmunu. In this higher dimension, macroscopic spatial and temporal coordinates, as we perceive them on the brane, do not exist. In effect, the string transits through a non-space and non-time. Instantaneous entanglement. Two entangled particles do not communicate by exceeding the speed of light c on the brane. They are connected by a single string extending into the bulk. Because the distance between the anchor points on the brane drops to zero when projected along the extra-dimensional axis y in the bulk, interaction and state transfer occur instantaneously. There is no violation of local relativity, as information does not cross the brane's space string grid at superluminal speeds, but flows through the geometric shortcut of the bulk. Das Bulkbrane. One of the greatest mysteries of quantum physics is entanglement. Two particles separated by billions of kilometers appear to communicate instantaneously. Einstein called it spooky action at a distance and rejected it. CQC resolves the mystery through a purely geometric explanation via the concept of quantitative limbo. Imagine a two-dimensional sheet of paper. Two ants are on opposite ends of the sheet, 1 meter apart. If the sheet is folded into a U-shape in our three-dimensional space, the two opposite points can come nearly into contact, separated by only a tiny fraction of a millimeter of air. When two particles are entangled, they are not isolated, they are connected by a single elastic string that does not lie on the surface of the paper, but instead hangs or extends through the shortcut of the bulk. When we measure the state of particle A on the brane, tension is transmitted instantaneously along the string through the bulk to particle B. There is no signal traveling across the space of the brane faster than light. The information simply took an extra-dimensional shortcut, where the macroscopic distance is zero. Delta bulk distance on the brane equal to zero in the bulk. This limbo is also the place through which the photon temporarily transits when unobserved, mechanically explaining why it behaves as an immaterial wave until it touches the brane again.